What specific problem does the Gemma 2 method aim to solve, particularly in the context of improving small language models?
The Gemma 2 method specifically aims to address the limitations of small language models, which have shown only marginal performance improvements despite extensive training on large datasets. The paper highlights that small models often require up to 15 trillion tokens to achieve minimal gains, indicating they are undertrained. To overcome this, Gemma 2 employs knowledge distillation, where a larger model serves as a teacher to provide richer gradients to smaller models, enhancing their training efficiency. This approach allows the smaller models to simulate training on a significantly larger quantity of tokens, over 50 times the compute optimal amount, without solely relying on increasing training length. Consequently, this method leads to substantial performance improvements in small models, making them competitive with larger counterparts across various benchmarks.
How does the proposed knowledge distillation method work? Illustrate the process step by step, including the mathematical formulation presented in the paper.
The proposed knowledge distillation method involves training smaller models, students, using the output probabilities from a larger model, teacher. The process begins by using the teacher model to compute the probability distribution of the next token given the context, denoted as P_T x vert x_c. The student model then aims to learn this distribution by minimizing the negative log likelihood between the teacher's probabilities and its own predicted probabilities, P_s x vert x_c. This is mathematically formulated as min_p_s sum _xp_t x vert x_c log p_s x vert x_c. In this formulation, the student model adjusts its parameters to align its output distribution with that of the teacher model, effectively learning from the richer information provided by the teacher's predictions rather than relying solely on one-hot encoded targets. This method allows the student models to benefit from the extensive training of the teacher, leading to improved performance even when trained on fewer tokens.
What are some theoretical or practical benefits that the Gemma 2 method offers over existing alternatives in the field of language modeling?
The Gemma 2 method offers several theoretical and practical benefits over existing alternatives in language modeling. Firstly, it employs knowledge distillation, which enhances the training of smaller models by providing them with richer gradients derived from a larger teacher model, allowing for improved performance without solely relying on increased training data. This approach enables the smaller models, such as the 2B and 9B versions, to achieve significant performance gains, up to 10% in some benchmarks, compared to previous models trained on similar token counts. Additionally, Gemma 2 incorporates advanced architectural features like grouped query attention, GQA, and a combination of local and global attention mechanisms, which optimize inference speed and maintain performance. Furthermore, the models are trained on vast datasets, up to 13 trillion tokens, ensuring a diverse and comprehensive understanding of language, which is crucial for applications in various domains such as question answering and common sense reasoning. Overall, these innovations position Gemma 2 as a competitive alternative, even against larger models, while also addressing safety and ethical considerations through rigorous filtering and evaluation processes.
Can you explain the process used for validating the effectiveness of the Gemma 2 models? What metrics or benchmarks were employed to demonstrate their performance?
The effectiveness of the Gemma 2 models was validated through a comprehensive evaluation process that included both automated benchmarks and human evaluations across various domains. Specifically, the models were assessed using standard academic benchmarks, such as the Hugging Face Evaluation Suite, where the 27B model was compared against similar-sized models like Qwen 1, 534B and Llama 370B, demonstrating superior performance. Additionally, the models underwent evaluations in the LMSYS chatbot arena, where they achieved high ELO scores, indicating strong performance relative to other state-of-the-art models. Human preference evaluations were also conducted, focusing on safety and instruction following capabilities, where Gemma 2 models outperformed previous versions and other models like GPT-4o. Furthermore, multi-turn conversation evaluations showed that Gemma 2 maintained high-quality responses throughout interactions, further confirming its effectiveness.
What significant results were achieved with Gemma 2 compared to prior models, especially in the context of benchmarks and human evaluations?
Gemma 2 achieved significant advancements over prior models, particularly in automated benchmarks and human evaluations. The 27B model, trained without distillation, outperformed similar-sized models like Qwen 1, 534B, and was competitive with the larger Llama 370B, demonstrating superior performance in its size category. The 2B and 9B models, trained with knowledge distillation, showed improvements of up to 10% in some benchmarks compared to previous versions, confirming that distillation enhances model quality even with the same token count. In human evaluations, Gemma 2 models excelled in the LMSYS chatbot arena, with ELO scores indicating they outperformed all other open models in their parameter range. Additionally, Gem 2 models demonstrated better user satisfaction and conversation goal achievement in multi-turn evaluations compared to the earlier Gemma 1 model.
What limitations did the authors identify for the Gemma 2 method, particularly regarding its application across different tasks or domains?
The authors identified several limitations for the Gemma 2 method, particularly concerning its application across various tasks and domains. Firstly, they noted that while thorough testing was conducted, it could not cover all potential applications and scenarios, emphasizing the need for users to perform rigorous safety testing specific to their use cases before deployment. Additionally, they acknowledged that the models are not multimodal and were not specifically trained for state-of-the-art multilingual capabilities, which may restrict their effectiveness in diverse linguistic contexts. Furthermore, the evaluation results indicated that while Gemma 2 models showed significant improvements over previous versions, their performance on certain benchmarks, such as code vulnerability detection and offensive cybersecurity tasks, remained low compared to more advanced models like Gemini 1.5 Pro. Lastly, the authors pointed out that the model's memorization rates, although low, still presented a risk of producing memorized training data under specific circumstances, which could affect their reliability in sensitive applications.